Hi, I'm Dr. Michael Grieves of the Digital Twin Institute, and I had hoped to be in Boise today to address you in person. However, nature has gotten in the way in the form of Hurricane Milton, who has completely disrupted travel plans out of my state of Florida. So I think you're going to have to settle for my digital twin, which may be appropriate given the conference, that is going to talk about reality capture, digital twins, and the Digital Twin Metaverse, moving 21st century work into the virtual world. I'm going to give you a view of where I believe digital twins are, how reality capture figures into the digital twin model, and what I perceive is going to happen in the future. I'd like to start off by showing you the original digital twin model that now, it's hard to believe, but it's over 20 years old. It didn't have a name. It was called the Conceptual Ideal for Product Lifecycle Management, or PLM, but it had these components. I'll point you to the little VS1 to VSN spaces down in the lower right corner that you'll see have been eliminated from the current model, but it was to indicate the fact that while we had one real physical space, we could have multiple virtual spaces. And this model is pretty much the model that exists today, and it will have relevance later on when I talk about the metaverse. So what is the digital twin? I'm often asked that particular question, and I'm often asked for definitions. And I do not think that definitions capture what digital twins are, and especially since definition in English would have to be translated into other languages, and I think things get lost in translations. What I much prefer to do is look at digital twin models, which are visual representations of what I'm talking about in terms of what digital twin is. And I take a pretty broad view of the digital twin. It has three components that I will talk about in a second that basically makes it a digital twin. If it has these three components from my perspective, it can exist as a digital twin. The first part of this is on the left-hand side, you see physical objects in the physical environment. And the idea here is the fact that we live in a physical world, and if we're going to do anything, it requires physical products and physical activity. We can't get around that. We have to actually expend time, energy, and material in terms of trying to accomplish the tasks that we set out to do. On the right-hand side, we have what I call digital or virtual space. And quite frankly, this is the new feature that we have gotten from the advances in computer technology that effectively started in the middle of the last century. I mean, the ability of having digital products in digital space is this ability of having digital twins. We can, in essence, if you think about it, strip the data and information from the physical products and basically recreate that into this digital virtual space. Well, third component, and what makes these digital twins, is the ability of basically taking data from the physical world and being able to then populate and create these digital environments and the digital reflection of what exists in the physical world. And then the whole purpose of this is to basically use that data and information over in the physical world in order to be more effective and efficient. And the reason we wanted to do this is because in the 20th century and before, we were pretty much limited to this physical space. If we had an idea of a new product, it had to take physical form, a drawing, a blueprint, a physical prototype, so that we could share it among other humans that were involved in it. In the 21st century and beyond, we are able to move this work activity over into the digital virtual space in order to be able to share our ideas and data and information that we could not do before. And the reason we want to do that, as I will talk about a little more extensively, is we want to substitute this information that we're creating for the wasted physical resources we need to complete tasks. When I talked about the model, I talked about the fact that we were going to move work from the physical world into the digital virtual world. And the underlying premise of digital twins, and in point of fact of digital transformation, is this idea that information is a substitute for task-wasted time, energy, and material. And all of human existence in our physical world is what we do is we goal-seek activity while we try to minimize physical resources. We live in a physically constrained world, and therefore, what we need to do when we're doing our task is to try to minimize our resources. And the bar on the left-hand side here realizes that particular concept in that I can take any task that I am looking at, whether it is designing a quality product or building and manufacturing a quality product, or even using a quality product to accomplish my task, is I can divide that task into two parts. The green bar is the minimal amount of physical resources that I would use for completing that task. Everything above that is what I call information inefficiencies, or in essence, to be simpler about it, is that it's wasted resources. We can cost those resources as time, energy, and material and be able to put a cost on what it takes us, in essence, to design a product, to manufacture that product, and to then support it and operate that product. And our intent here is we would like to use the minimum amount of physical resources that we possibly could in order to be able to do that. In fact, in manufacturing, we call that lean manufacturing. And our intent is to be as lean as we possibly can so that we're not wasting physical resources and that we are, in essence, being able to do things as efficiently and effectively as we possibly can. Where information comes in is the fact that it replaces not the physical resources that I need to do my goal-seeking tasks, but for the wasted resources. Now, the blue section here shows it replacing all information inefficiencies or wasted resources. But in our human endeavors, that's not going to happen. But it is to convey the idea that information is an ability to basically be able to reduce wasted resources. The other advantage here with information is what is called a non-rival resource, in that over on the left side, when I use physical resources, and in fact, when I waste physical resources, I basically cannot reuse those resources. On the right-hand side with information, when I use information to replace wasted resources, I don't use up that information. I can use it over and over again. So there's huge opportunities. Now, the issue of it is that we don't have a unit of measure for information resources, but we can actually get there with a proxy of hardware, software, and humans' time. Information is not free. It costs us something to develop it. But once we develop it, it basically can, in essence, be used over and over again without using it up. Where does this make sense to do? It makes sense to do when the cost of information for all the times that I'm doing the task is going to be less than the cost of wasting time, energy, and material. If I have a one-time task, it doesn't make sense for me to create an information system or develop an information system to, in essence, replace the wasted resources. But if I'm doing this task over and over again, and I'm doing similar tasks that this information can, in essence, help me replace wasted resources of time, energy, and material. And time, especially elapsed time, is our most scarce resource. We cannot recover the time of a clock that basically passes us by. And so this is the idea behind digital twins, digital transformation, and why we're seeing such a pressure to, in essence, move our work from the physical world into the virtual world. So I've been asked the question, and this topic I've seen be bantered about is, does reality capture have anything to do with digital twins? And I'd like to kind of poke at that because I think that it is obviously very relevant to this conference. But remember, my three elements of digital twins are physical objects in our real world physical environment, digital twins in a digital environment, and the connection between physical and digital for data and information. So the model there shows that I get data from my physical world and populate my digital virtual world. And then I use that data information in the physical world, as I just talked about, in terms of replacing wasted resources in our goal-oriented tasks. And so in terms of reality capture, if we go back through this, clearly we do have physical objects in our real-world physical environment. That's obviously what we're capturing. What we're doing is creating digital twins in a digital environment. So we have that kind of capability. And the third is we're doing this because we want to do work in the real world and use this kind of capability. So we have a massive physical world, and somehow we need to, in essence, recreate that world in our digital virtual space. And while we could do that from scratch in terms of developing this kind of same models of our physical world, reality capture allows us to do this in a very efficient manner. So a lot of the real world doesn't change on a constant basis. So we want to basically be able to, in essence, capture infrastructure, buildings, things that have low level of changes, and be able to populate our digital virtual world in order to actually do work in our physical world using that data information that we've collected. The scope and scale adoption of the digital twin model has exploded over the last half a decade to decade. And I'm going to talk about tangible products, although digital twins are equally applicable to intangible. But since we're talking about reality capture here, I want to focus on tangible things that we can feel and touch. And so we're seeing digital twins in terms of the automotive, in terms of all kinds of transportation, including locomotive, power distribution systems, aerospace and space applications, ships and port applications, and certainly oil production in all types and forms. We're seeing it in terms of smart buildings, smart cities, and we're even seeing efforts in the digital twin of the entire Earth. We're seeing digital twins of people and the pharmaceuticals they take, but from a physiological standpoint, not from their behavioral standpoint. So this explosion is occurring very rapidly, and we are seeing all kinds of applications. If you can think about the application and you have a tangible product, you can probably use digital twins. But it means that reality capture is important because all these things generally have infrastructure that is attached to it that we need to, in essence, bring along with the products. So we have two categories of the digital twin model. We have the digital twin itself that we've been dealing with for a while now. And we now have added to that the reality capture of the digital twin environment. And this is not simply a pipe dream. We are doing this today. And the examples here on the left side is the digital twin of the new SLS moon rocket that's being developed by NASA. And on the right side is a digital twin environment, which is the Michoud manufacturing facility that's outside of New Orleans, where NASA is manufacturing that. And NASA has reality captured the entire facility, which is the largest manufacturing facility under air conditioning in the world, in order to build this rocket there. So this is actually happening today. And if you're interested, there is a new book coming out within the next month or so that I'm co-editing called Digital Twin Simulation in the Metaverse. And this chapter is NASA's Michoud Assembly Facility developing a factory digital twin. So this is actually happening today. And again, while the digital twin is important and the digital twin here of the SLS rocket is very expensive and was being developed from scratch, the Michoud facility has existed since World War II that basically allows us to take and reality capture that infrastructure in order to be able to use this kind of capability. So we're not talking about science fiction here. This is actually happening, and I expect to see many more instances of this occur. So how are we progressing in terms of the digital twin evolution? And if I look at it on a timeline from the physical to virtual maturity, and I look at the evolution of information, I come up with this sort of progression that is where we are going. And if you remember, the digital twin has been around for 25 years at least as a digital twin model, but it's only been recently where the computing capability, storage, and processing have in essence allowed us to do the sorts of things that was envisioned from this early on. Initially, as I had said, is that as soon as we had something physical, it had to take physical form in terms of a product. And so if we had an idea to create a physical product, we basically had to, in essence, create a drawing, a blueprint, or even a physical prototype in order to convey this idea. And this occurred right from the beginning of time until fairly recently. The 2000s marked a real change in our capability in terms of being able to move into a digital virtual environment. We moved from 2D representations, as in blueprints and drawings, into 3D model. This was a major quantum leap in terms of our ability of being able to visualize in digital form the products that we were looking at. And this occurred in the early 2000s, where we moved from in essence, flat blueprints or even flat models into three-dimensional models. We are in what I call the ad hoc period right now, where we basically have digital twins, and in fact, they're proliferating at an amazing rate, but they're pretty much independent and they're ad hoc. If we really want to have digital twins, and in fact, digital twins that interoperate with each other, we have to do some brute force programming in order to make that happen. While there are advances that are occurring in this particular area, we think that is the requirement is we have to, in essence, do those ourselves. We are going to move rapidly into what I call the digital twin platform, which is going to allow us to replicate what's happening in the physical world into the digital world. So that's going to be a digital twin platform. And then where I think this is going is what I call an intelligent digital twin platform, which is showing on a crystal ball looking into the future, where we're going to have a thing I call front-running simulation, which is at every time zero to be able to predict what the product is going to do with probabilities so that we can, in essence, avoid having issues so we do predictive maintenance that basically allows us to fix problems before they occur. And so we are rapidly approaching this particular area, and how we're going to have this interoperability of digital twins is sort of our next big problem to take a look at. So, as I mentioned from the previous slide, we are moving and evolving into this multiple digital twin platforms where we are no longer just concerned about the digital twin itself and how it behaves, but how it behaves in a particular environment. I had always talked about this earlier on and called it the digital twin environment, but the nomenclature that we're settling on now is what I'm calling the Digital Twin Metaverse. And there is a book coming out with my chapter talking about what will be the characteristics of this environment or digital twin metaverse that will allow multiple digital twins to interact with each other. And clearly, there's a reality capture aspect here because we will need to have the infrastructure and the environment that surrounds these particular products that has already existed. And so we're going to develop products not for existence into an empty universe, but in one that we currently populate that has a lot of infrastructure that will need to coexist with whatever we're developing. And so what are these characteristics that we're going to be talking about? There are going to be multiple digital twin metaverses. If you remember my original slide where I had these sub-virtual spaces, we are going to, in essence, have that kind of capability. We have one physical universe that we deal with, that we know of anyway, unless you believe in alternate universes, but we will be able to have multiple digital twin metaverses that we will use for different kinds of functions, and in fact, be able to do different predictions based on the same initial assumptions to see which one meets our needs the best. We're going to have digital twin interoperability. So that means as we do reality capture, we're going to have interoperability with the digital twins that we're developing to, in essence, coexist with the environment that they have to deal with, whether it's going to be a city, a plant, or any other kind of environment that we've reality captured. Digital twin interoperability, the ability to coexist and have the same kinds of capabilities is going to be a requirement for our digital twin metaverse. The laws of our physical universe are implemented and enforced in simulations for all inanimate objects. So we are going to have the same rules for all our inanimate objects that exist in this. So whether we have reality captured them or whether we're designing a new product from scratch and created a digital twin that we're looking at its behavior for, we're going to have the same in terms of rules of gravity or force or time that exist for each and every one of them at the same time. The DT metaverse will support both replication and prediction. This is key. We need to have replication of what's happening in our physical world so that we, no matter where we are in the world, simultaneously and instantaneously can know what's happening with our digital twins in the environment that they're in. And then what we really want to do is predict their performance so that we can, in essence, pick the behavior or plan of action that will minimize our goal task resources. As I said, what information is all about is replacing wasted resources in terms of our goal-oriented tasks. We're going to have, unlike we currently have in terms of digital twins, a multiple participant immersive metaverse as people as XR avatars. So we would like to have people interact in terms of our environment and also with the products that we are developing or trying to model and simulate in our metaverse. So we want to be able to have this replication and prediction, and we want to have people interact with them. They could go out onto the factory floor and actually tinker with the production to see which production capability is best. This is, in essence, the definition of lean manufacturing. We want to allow meta capabilities for human participants, so we could allow them to see through walls or even walk through walls as long as they're not doing plant walkthroughs. But we will allow these meta capabilities so that people could instantaneously move from location to location in our reality capture model, and we will be able to be much more effective and efficient in being able to do that. In essence, it gives us kind of superhuman powers, although we're calling those meta capabilities. Time can be synchronous or asynchronous with physical time, depending on use case and digital twin type. So we could basically have our time synchronous for what's happening in the actual world, if we're, say, on a manufacturing plant floor or we're in a smart city environment, that basically shows us what's happening so that we can have a feel for that. But we can also speed up time so that we can see what might happen if we basically do certain particular actions. And so this, obviously, time can be synchronous or asynchronous, but it needs to be sort of consistent across the entire metaverse that we're talking about. And finally, this thing that's always bothersome to me is that cybersecurity is embedded in all aspects. And so we no longer have the ability of having a fortress mentality where we can hide our physical things behind walls, fences, guards, and things like that. We're going to need to have omnipresent cybersecurity so to make sure that only individuals and capabilities that we authorize are going to occur within our digital twin metaverse. And so reality capture is a big part of that, because in order to have a metaverse or environment, we're going to have to capture the existing infrastructure and existing products and capabilities that will currently exist that we need to basically move over in order to be able to have our new digital twins be able to interact with them. So reality capture and the digital twin metaverses are highly complementary. The digital twin metaverse requires duplicating physical assets. But the physical world has a large class of unchanging or infrequently changing existing assets that we will need to have in our digital twin metaverse. And the ability to get them into this digital world is the ability of being able to do reality capture. Some digital twins will be created de novo, but there is a large amount of the world that is either unchanging or infrequently changing that we can basically import into our digital twin metaverses using reality capture. Once captured, they can be used in multiple digital twin metaverses. And this will give us the ability of reusability in terms of that. I mean, we only have one physical world where the physical thing is in existence, and as it changes, we have no control over. We can basically have reality capture where we can keep different versions of what was the reality and be able to use them for different modeling and simulation purposes. Physical assets can be merged with underlying IoT data. In the physical world, everything has to be combined. In the digital twin metaverse, we can basically have our physical assets and yet produce what behavior that they're undergoing in terms of, say, pipe flow or current stress tests with underlying IoT data. So because information is and data is granular, we can basically have this ability of merging our reality capture assets with new up-to-date data of what's actually occurring with them. So reality capture and the digital twin metaverses are in essence highly complementary, and we were going to need reality capture if we're really ever going to have digital twin metaverses that will allow us to do product replication and prediction. If you're interested in doing more research on digital twins, this is a list of selected publications from the past 20-some years. It starts off with the original book on product lifecycle management, which had the model of the digital twin as it was first presented. And it includes a book that is just coming out. In fact, I received the proofs today. That's called Digital Twins Simulation in the Metaverse, Driving Efficiency and Effectiveness in the Physical World through Simulation in the Virtual Worlds. I also have a YouTube channel out there that you can select, and there are a number of presentations that you can basically watch from that channel. But if you're interested in that, this is a pretty good list of my work in this particular area. And with that, again, I'm sorry that I couldn't be there, but Milton, the hurricane, prevented that. Who names a hurricane Milton? Anyway, I hope you have a great conference. And again, I'm just sorry that I'm missing it. Thank you very much.